Welcome to Module 7. We're almost done this 8-module course in Introductory Business Statistics. Module 7 now, we're going to be looking at these things called sampling distributions. So this follows very much from Module 6, where we were looking at different probability distributions. So in that module, we were looking at the uniform distribution, the normal distribution, and the exponential distribution. And each of those distributions, we were discussing how they can be used to determine the probability of a particular event occurring. Now, what we're going to be looking at is using particularly the normal distribution and describing how we can take samples from a population that is normally distributed and draw some conclusions. This is going to be really the basis for what we call the process of inference. So let me just explain a little bit what I mean by this. We differentiate between the population and the sample. Of course, the population can be a finite population, meaning that there exists some maximum number of observations within a population. So maybe the number of students at the university this year. Now there's maybe 25,000 students at the university. That's a finite population. There's no more, there's no less. That's how many there are. Or we could consider an infinite population, in which case maybe it's we're looking at all of the students at the university since the university began. So there's students coming in, there's students who are leaving, and there's always this churn of new graduates being put out, like a manufacturing line, right? We're manufacturing over time. There's no upper limit to that number. So a finite population, there's a prescribed maximum number. An infinite population could be a process that's taking place over time. So what we're going to be doing is looking at taking samples from each of those different types of populations. So what that means, a sample is really taking a subset of observations that exist within that population. So if it's a finite population, maybe I'm reaching into that population. We'll look at different sampling methods, and here maybe I'll take this as my subset of that population, or an infinite population. Now maybe I take a sample, a subset of those observations at a particular moment in time. What we're going to then be doing is looking at calculating point estimates. So we're going to be using information contained in those samples, and we can estimate sample means as a point estimate of the true but probably unknown population mean. We'll be using estimates of the standard deviation as a point estimate for the population standard deviation. We'll be using sample proportions in the case where we're looking at using the normal distribution to approximate binomial probabilities. We can calculate the sample proportion as a point estimate of the unknown population proportion. So we're going to be looking at how are these particular point estimates distributed within a population. So if we consider, for example, a normal distribution, something that looks, it's that bell curve distribution, and it has some population mean mu. Well, we understand now how individual observations exist within that distribution. There's some particular standard deviation. There's a spread of observations within that distribution. What we'll be looking at now are the distributions of the point estimates or the sample mean specifically. So if I take a sample out of this distribution, maybe that sample mean is here, and there's some particular distribution around that sample mean. Maybe that sample mean is out here, maybe it's out here. We don't know. What we do know is how it's distributed, and this is what we call the standard error. So a standard deviation divided by the square root of the sample size. And this gives us some idea of how those point estimates, in this case those sample means, how are they distributed within that population. And then we can use that information later on to make different types of inferences or draw conclusions about what that true unknown population parameter might be. So that's maybe a lot to take in. This is where we're going in this chapter. We're going to be looking at all of these different sampling distributions and point estimates of these unknown population parameters. Okay, so hopefully all of the problems will be interesting and hopefully they'll make sense. Let's get to work. Thanks for watching.